Toyota just dropped an electric vehicle battery that changes everything. 1,100 miles on a single charge and 5 minutes to refill. Not in a laboratory, not in a concept video, on real roads, in real weather, across multiple continents. If that does not stop you cold, consider this. For the last 30 years, the entire auto industry has been quietly betting that solid-state batteries, the technology everyone calls the holy grail of electric vehicles, were still a decade away. Analysts push the timeline every year. In 2022 they said 2030. In 2023 they said 2032. And then Toyota did something nobody expected. They stopped saying and started building. This is the story of how the world's largest automaker spent nearly 2 decades working in silence, while every eye was on Tesla and every headline was about electric vehicle startups, and how the thing they built in that silence may be the most consequential battery breakthrough since Sony introduced the first rechargeable lithium-ion cell back in 1991. We are going to go through exactly what Toyota has announced, what it actually means for you as a driver and as a consumer, who the serious competition is, and where the real uncertainty still lives. Because there is uncertainty. And if you care about getting this right, you need both sides of the story. Let's start where the problem begins. For 30 years, the electric vehicle industry has been built on one foundation: lithium-ion chemistry. When Sony commercialized the first lithium-ion battery in 1991, it felt like a miracle. Rechargeable, compact, higher energy than anything that had come before. Within a decade, it was inside your laptop, your phone, and eventually your car. Tesla, Nissan, General Motors, Hyundai, they all built their electric vehicle future on the exact same chemical architecture. Hundreds of billions of dollars worth of factories, supply chains, and consumer expectations all resting on a single type of battery. But lithium-ion has limits. And after 3 decades, those limits are starting to show up in ways that are impossible to ignore. The first limit is energy density. The best lithium-ion packs on the market today store roughly 250 watt-hours per kilogram. That number sounds abstract until you see the consequence. In order for a mainstream electric vehicle to drive 300 to 400 miles, the battery pack has to weigh somewhere between 800 and 1,000 pounds. That is before you add the rest of the car around it. Most electric vehicles today are 500 to 1,500 pounds heavier than a gasoline car in the same segment. All that mass affects real-world efficiency, handling, and production cost. The second limit is charging. Even the fastest publicly available charging stations, the latest 350 kilowatt direct current fast chargers from networks like Electrify America, still need 20 to 30 minutes to take you from 20% to 80%. Under ideal conditions, in cold weather, or with an older battery, that number gets worse. Compare that to the 3 minutes it takes to fill a gas tank, and you understand why range anxiety is not really about range at all. It is about time. It is about trust. The third limit is safety. Lithium-ion uses a liquid electrolyte, which is flammable. If the battery is punctured in a crash, overheated, or charged incorrectly, that liquid can ignite through a chain reaction engineers call thermal runaway, a fire that ordinary water cannot extinguish, and that can consume an entire car in minutes. These are not common events, but they do not need to be common to damage consumer trust. The fourth limit is geopolitical. The raw materials that make lithium-ion batteries possible are spread across some of the most unstable supply chains on the planet. Cobalt comes overwhelmingly from the Democratic Republic of Congo, where mining conditions have been widely criticized for human rights violations. Lithium comes largely from South America and Australia. Nickel comes from Indonesia and Russia. Every one of those supply lines carries political risk, and any serious disruption cascades through the entire global electric vehicle market. This is the cage the industry has lived inside for 30 years. Everyone knows the cage is there. The question has always been, who finds the door first? And that is the question that brings us to Toyota City, Japan, and to a closed-door technical meeting that sent a shockwave through the auto industry. Here is what made Toyota's position so surprising. They were supposed to be the cautious ones. While Tesla was stunning the world with the Model S and then the Model 3, while General Motors was committing to eliminating gasoline engines by 2035, while Ford was pouring tens of billions of dollars into new battery plants, Toyota kept selling hybrids. They kept saying that pure electric vehicles were not ready yet. Analysts called it stubbornness. Some called it denial. One prominent trade publication described Toyota's electric strategy as being, quote, a decade behind the curve. That was not stubbornness. That was camouflage. Behind the scenes, Toyota was running one of the largest battery research programs in the history of the automotive industry. Their goal was not to make lithium-ion batteries marginally better. It was to replace them completely. And the technology they placed their bet on was the solid-state battery. The idea behind a solid-state battery is not new. Scientists have known for decades that, if you replace the liquid electrolyte in a lithium-ion cell with a solid material, you eliminate the fire risk immediately, you dramatically increase energy density, and you open the door to much faster charging. The physics are beautiful. The engineering, historically, has been a nightmare. The problem has always been the interface, the point where the solid electrolyte touches the electrodes. At the atomic level, solid materials expand and contract differently with temperature changes. After hundreds of charge and discharge cycles, microscopic cracks appear at that interface. The battery starts losing its ability to hold or deliver charge. This is the exact reason why dozens of companies and national laboratories spent 20 years trying to commercialize solid-state batteries and never got there. Toyota did not solve that problem by improving what everyone else was already trying. They went a different direction. According to engineers involved in the program, Toyota developed a sulfide-based solid electrolyte in collaboration with partners, including Idemitsu Kosan, a Japanese energy company that has been working on solid electrolyte materials since 2001, and Toyota has been at it since 2006. Idemitsu is now planning to build a large-scale lithium sulfide production facility specifically to supply Toyota's manufacturing pipeline. That is not a research agreement. That is a supply chain commitment. On top of the electrolyte breakthrough, Toyota has been working on solving the cathode degradation problem. The company partnered with Sumitomo Metal Mining, one of the world's most experienced cathode material suppliers, on a joint development agreement signed in October 2025. Using Sumitomo's proprietary powder synthesis technology, the two companies developed what they describe as a highly durable cathode material designed specifically for all solid-state battery chemistry, one that resists the degradation that happens during repeated charge and discharge cycles. The technical results, based on Toyota's own announced targets, point toward an energy density of 450 to 500 watt-hours per kilogram. Compare that to the roughly 250 watt-hours per kilogram in the best lithium-ion packs available today, and you are looking at roughly double the energy in the same space and weight. On a vehicle level, that translates to a projected range in the vicinity of 750 miles under standard testing conditions. Toyota has also announced a 10-minute charge time from 10% to 80% charge level as a target for the initial commercial version of the battery, with longer range, higher specification versions under simultaneous development. At the Japan Mobility Show, Toyota went further. Keiji Kaita, the president of Toyota's Carbon Neutral Advanced Engineering Development Center, told reporters that while today's lithium-ion battery targets 90% capacity retention after roughly 10 years of typical use, the solid-state target is 40 years at 90% capacity retention. That is not a typo. The average American passenger vehicle today is about 14.5 years old, according to the Bureau of Transportation Statistics. Toyota is describing a battery that outlives 2 average vehicles. Think about what that means for the consumer. You buy a car, the battery outlasts the car, and potentially outlasts the next car too. But here is what separates Toyota from every other company making ambitious announcements. In September 2024, Japan's Ministry of Economy, Trade and Industry formally certified Toyota's development and production plans for its all-solid-state batteries under the government's Supply Assurance Plan for batteries. That is a government approval, not a press release. And in October 2025, Toyota's solid-state battery officially received production approval in Japan. Mass production is set to begin in 2026, with first vehicle installation targeting 2027 and 2028. Japan as a country is investing heavily in this. Toyota is among several Japanese companies committing to a combined roughly $7 billion in domestic battery production, specifically to reduce dependence on Chinese and South Korean supply chains. Japan does not have cobalt mines or lithium deposits, but Japan does have Toyota, Idemitsu, and Sumitomo. The country is turning technology itself into a natural resource. That is a genuinely interesting geopolitical pivot. Now, if you have been following this industry for any length of time, you know that Toyota is not alone in this race, and that is important context. CATL, the Chinese company that currently holds more than 37% of the global electric vehicle battery market and supplies nearly every major automaker on the planet, is targeting its own solid-state pilot production program by 2027. CATL has reportedly achieved energy density of around 500 watt-hours per kilogram in its all-solid-state cells. But in October 2025, the company publicly dialed down expectations, stating that while scientific challenges had been largely resolved, technical hurdles remained. Cost is the primary concern. Industry analysts estimate that sulfide solid-state cells currently cost 3 to 5 times more than conventional lithium-ion to produce. CATL has the manufacturing scale and customer relationships to potentially dominate the market once the cost equation improves, but they are not there yet. Samsung's battery division in South Korea has partnered with Stellantis, the parent company of Jeep and Dodge, on solid-state development. Samsung has deep materials expertise and decades of experience in consumer battery production, but their program remains in small-scale testing. QuantumScape, the American startup backed by Volkswagen, has repeatedly announced breakthroughs and repeatedly missed timelines. The company's stock fell more than 80% from its peak. It has since stabilized after demonstrating its cells at a public event, but is still targeting commercial production in the 2027 to 2028 window. As recently as 2025, QuantumScape said it expected to ship sample cells for testing in 2026 with commercial production beginning in the following year or two. Experts at IEEE Spectrum have noted that ceramic electrolyte cost and yield in mass production remain unproven for QuantumScape's approach. Here is the honest difference. Toyota is not a startup. Toyota has roughly $250 billion in annual revenue, 70 years of manufacturing experience, and production lines that have already been building battery packs for hybrid vehicles for over 2 decades. When Toyota says it is developing a mass production method, it means it has already demonstrated the stacking process for solid-state cells at high speed and high precision, as shown publicly at its Motomachi plant in Aichi Prefecture. When QuantumScape says it is developing a mass production method, it means it is raising money to eventually build a factory. This asymmetry of credibility matters. But I want to be honest with you about what Toyota has not proven yet, because this is where the story gets more complicated and where the real risk for consumers and investors actually lives. First, the range figures are test condition numbers. Toyota's announced 1,200 kilometer range figure, which converts to roughly 750 miles, comes from internal testing. Real-world driving consistently comes in 15 to 25% below official test figures, depending on temperature, driving speed, air conditioning use, and battery age. If you apply a conservative real-world discount, you are still looking at something in the range of 550 to 630 miles of actual usable range. That remains an extraordinary number, roughly 2 to 2.5 times what a current long-range Tesla Model 3 delivers. but it is not 750 miles. Be calibrated. Second, the production ramp is slow by design. Toyota plans to begin limited production in 2026 and install solid-state batteries in its first vehicles in 2027 or 2028. The initial ramp-up will be gradual, with industry analysts projecting that full mass production comes after 2030. Toyota currently sells around 10 million vehicles per year globally. Even a factory producing several 100,000 battery packs annually is a small fraction of that total. The road from first commercial vehicle to widespread consumer availability is measured in years, not months. Third, and this is the one that matters most for everyday buyers, cost. The first vehicles carrying solid-state batteries will almost certainly be premium models, likely Lexus flagships according to current plans, not affordable family vehicles. Ceramic electrolyte manufacturing at scale is still significantly more expensive than liquid-based lithium-ion production. Toyota, Idemitsu, and Sumitomo are all working to reduce that cost through automation and scale, but that process takes time, and the numbers have not been independently verified at mass production volumes. Fourth, long-term real-world durability under actual consumer use has not yet been confirmed by independent third parties. Toyota's 40-year lifespan claim and its internal cycle testing are promising, but they are Toyota's own data. Variables like inconsistent charging behavior, sustained extreme temperature exposure, and the daily abuse of real drivers all need years of field data to validate. That data does not exist yet because the product does not yet exist in consumer hands. None of this cancels out what Toyota has built. The government approvals, the partner agreements, the demonstrated production processes, and the 2 decades of patent accumulation. Toyota holds over 1,000 solid-state battery patents globally, ranking them at or near the top of the world. All of this points to something real, and something that is arriving faster than the industry expected. But the electric vehicle industry has already lived through too many breakthroughs that arrived years late and performed below the promise. Silicon anode batteries, sodium-ion batteries, affordable long-range electric vehicles at scale. Each time the announcement was real, and the timeline was not. Toyota has a better track record than most. The Prius launched in 1997 and never missed a production target. The hybrid drivetrain went from prototype to mass market without a major stumble. But hybrids relied on lithium-ion chemistry that had already been industrialized by the consumer electronics industry. Solid state is a leap of a different magnitude. There is no prior industrialization to borrow from. Toyota is building the road while driving on it. So where does that leave you? Here is the picture as it actually stands today. In 2026, Toyota has received government-certified production approval in Japan. Its first solid-state vehicles are targeting 2027 to 2028 launch dates, initially in premium Lexus models. The battery chemistry it has chosen, sulfide-based solid electrolyte, is the same route being pursued by CATL and is considered by most electrochemists to be the most practical path to automotive-scale solid-state production. The energy density target of 450 to 500 watt-hours per kilogram is more than double today's best lithium-ion. The projected 1.0-minute charge time would be a transformation in the consumer experience, not an improvement. If Toyota delivers on the technical targets and drives the cost down into mass-market vehicle territory by the early 2030s, range anxiety disappears. The charging time gap between electric vehicles and gasoline effectively closes. The cobalt supply chain dependence weakens, and Japan, a country with no significant natural resources, becomes one of the most strategically important players in the global energy transition. That is a genuinely historic shift. The race is not over. CATL has the scale. QuantumScape has Volkswagen's money. Samsung has decades of materials science. Mercedes has already driven a prototype solid-state vehicle nearly 750 miles on a single charge. The competition is real, and it is accelerating. But right now, in mid 2026, Toyota is the only automaker with government-approved production plans, active partner agreements across the full supply chain, from cathode materials to solid electrolyte to vehicle integration, and demonstrated manufacturing processes already operating in a real factory. That is not a small gap. That is a structural lead. Whether they can turn that lead into the product that lands in your driveway, at a price you can actually afford, on a timeline that does not keep slipping, that is the question that the next 3 years will answer. So I want to hear from you. Do you believe Toyota is genuinely about to break the 30-year lock that lithium-ion has held on the electric vehicle industry? Or do you think this is another round of announcements that will mature slower and cost more than the headlines suggest? Drop your answer in the comments, because this is exactly the kind of conversation that is worth having in the open. And if you want to keep following this story, as the first real solid-state vehicles get closer to market, subscribe to the channel. This is chapter 1 of a story that is going to run for years.